All right, so today we're diving headfirst into one of the most mind-boggling concepts out there.
Yeah.
Like, truly, it's the kind of thing that makes you question everything you thought you knew about the universe.
Yeah, it's a bit of a brain melter.
Black holes.
Exactly. Just the name itself is enough to spark a million questions.
Oh, absolutely. We're talking about regions of space where gravity is so ridiculously strong that nothing, not even light, can escape. I mean, it almost sounds like something out of science fiction.
It does, doesn't it? But it's very much a science fact. And honestly, the deeper you dig into the science of it all, the more incredible it gets.
So we're going to try and do just that today. We've got this really amazing podcast script that we're going to be pulling from, and it does a fantastic job of breaking down the whole black hole phenomenon into manageable chunks.
It does. It's got all the good stuff, all the key insights, and it's actually pretty approachable, which is great.
Yeah, exactly. We want to make sure that we're delivering those mind-blowing facts in a way that everyone can follow along with. But don't worry, we're not shying away from the complexities either. So strap yourselves in, folks, because we're about to embark on a deep dive into the heart of black holes.
The one question that always pops into my head first is, how do these gravitational monsters even form in the first place? Like, where does it all begin?
Well, it all starts with stars.
Mm-hmm.
But not just any stars. We're talking about stars that are absolute titans, way more massive than our sun. Like, imagine a star that's at least, let's say, 20 to 25 times heavier than our sun.
Wow. That's already pretty hard to imagine. I mean, our sun is already pretty darn massive.
Right, exactly.
Yeah.
So these massive stars, they live fast and die young, just like rock stars, but on a cosmic scale.
Burning bright and burning out quickly. So I'm guessing this has something to do with the fuel they use, right?
You got it. Stars, they're basically giant nuclear reactors. They're constantly fusing hydrogen into helium, and that process releases an incredible amount of energy. And that energy is what makes them shine and also keeps them from collapsing under their own gravity.
Precisely. It's a delicate balance. But eventually, even the biggest stars run out of that hydrogen fuel. And when that happens, gravity takes over.
Uh-oh. So no more outward pressure to fight back against gravity's relentless pull.
Exactly. And with these supermassive stars, the collapse is, well, it's catastrophic. It's what triggers a supernova, one of the most powerful explosions in the universe.
A supernova. So that's when a star basically blows itself to smithereens.
Yeah, pretty much. A huge chunk of the star's material is flung out into space during a supernova. It's actually how many of the elements that make up you and me and everything around us are created. We're all made of stardust, as they say.
That's amazing. Okay, but how does the supernova explosion lead to a black hole?
So here's the thing. It's all about what's left behind after the fireworks. After the supernova, you've got the star's core. Now, if that core is massive enough, meaning it's still way heavier than our sun, gravity just keeps on crushing it.
Gravity, the ultimate cosmic bully.
It just keeps squeezing and squeezing that core until it reaches a point of unimaginable density.
Density. I remember the script mentioned a pretty wild analogy.
Yeah, this is one of my favorites. Imagine taking an entire mountain, like Mount Everest, and compressing it down to the size of a tiny marble.
A marble. I can't even wrap my head around how much matter that would be.
It's mind-boggling, right? That's the kind of density we're talking about with black holes. It's so dense that it warps the fabric of space-time itself.
And that's where things start to get really weird, and that's also where we start talking about things like the event horizon.
The event horizon. Yeah, that's the point of no return. It's like a boundary around the black hole, and once you cross it, well, there's no coming back. The gravitational pull is just too intense.
So even light, the fastest thing in the universe, can't escape the clutches of a black hole once it crosses the event horizon.
Nope. Light, spaceships, anything that gets too close is sucked in and can never get out. That's why they're called black holes. They're completely dark because no light can escape.
Wow. So that's the event horizon. And then deep inside the black hole, at its very core, there's something called the singularity, right?
That's right, the singularity. And to be honest, it's one of the most mysterious and mind-bending concepts in physics. It's thought to be a point of infinite density where all the matter that fell into the black hole is crushed into a single, infinitely small point.
Infinite density.
Yeah.
Infinitely small. It's hard to even grasp those concepts.
Yeah, it's beyond our current understanding of physics. It's where our current theories break down. It's like the ultimate cosmic enigma.
So we've got these mind-blowing black holes forming from the deaths of supermassive stars. But hold on. Our own sun isn't going to go out in a blaze of supernova glory and turn into a black hole, is it?
Don't worry, our sun is far too small for that kind of dramatic exit. When our sun reaches the end of its life, it's going to go out a bit more gently, puffing up into a red giant before eventually fading away as a white dwarf.
A white dwarf, so like a retired star, just chilling out in space.
Hmm. Exactly. Now, there are stars that are a bit bigger than our sun that might end up as neutron stars, which are also incredibly dense, but not quite black hole level dense.
So neutron stars are like the middle child of stellar remnants. Not as massive as a black hole, but still pretty extreme.
That's a great way to put it. They're like the super compressed versions of stars, packing a whole lot of mass into a relatively small space, but they have internal forces that prevent them from collapsing further into black holes.
All right, so we've covered the basics of how these stellar mass black holes form, but the script also talks about another type of black hole, something even more massive. Enter the supermassive black holes.
Supermassive black holes are the true heavyweights of the universe.
These are the ones that are like millions or even billions of times more massive than our sun, right?
You got it. They're monstrous. And they're not just floating around in space. They reside at the centers of most, if not all, large galaxies, including our own Milky Way.
Wow, so we have one of these supermassive black holes lurking in our own galactic backyard.
We do. It's called Sagittarius A, and it's about 4 million times the mass of the sun.
4 million suns. That's just insane. So how do these supermassive black holes form? Is it just a bunch of smaller black holes merging together over time?
Well, that's one of the leading theories.
Yeah.
You have a bunch of stellar mass black holes hanging out in a dense galactic center, and over billions of years, they collide and merge, growing bigger and bigger.
Like a cosmic game of Pac-Man, where the black holes just keep gobbling each other up.
It's a pretty good analogy. But there are other theories out there, too, like the possibility that supermassive black holes formed directly from the collapse of massive gas clouds in the early universe, bypassing the whole star formation process altogether.
So a lot of debate about their origin story, but no doubt that they're out there influencing the evolution of galaxies.
Absolutely. They're these gravitational anchors that hold galaxies together. They're also incredibly active with material constantly falling into them, creating these swirling disks of superheated gas.
Those are the accretion disks we talked about earlier, right?
Yeah, that's right. And these accretion disks can be incredibly bright, emitting powerful radiation across the electromagnetic spectrum. That's how we can actually detect black holes, even though they're invisible.
Right, because they're surrounded by this swirling, glowing material that's being pulled in by their gravity. It's like trying to see a shadow puppet, where the puppet itself is invisible, but you can see its outline against the light.
That's a great way to put it. And speaking of seeing black holes, the script mentions one of the most incredible scientific achievements of recent times, the first ever image of a black hole.
Oh yeah, that was huge. I remember seeing that image all over the news. It was in 2019, right?
That's right. And it was a truly global effort involving a network of radio telescopes all around the world called the Event Horizon Telescope.
So they basically linked up all these telescopes to create one giant Earth-sized telescope.
Exactly. And that's what they needed to achieve the incredible resolution required to image something as small and distant as a black hole. And remember, they weren't actually seeing the black hole itself.
Right, because black holes don't emit light.
Exactly. What they were seeing was the black hole's shadow, the silhouette it cast against the bright background of the hot, swirling gas in the accretion disk.
So what did this groundbreaking image actually look like?
Well, it was a bit blurry, but it clearly showed a bright ring of light surrounding a dark central region.
Like a cosmic donut.
Yeah, kind of. And that bright ring, that's the light from the superheated gas in the accretion disk being bent by the black hole's immense gravity. And that dark central region, that's the shadow of the event horizon, the point of no return.
Wow. It's just amazing to think that we're actually able to see, or at least infer, the presence of something that's fundamentally invisible.
It is, and it's a testament to the ingenuity and collaboration of scientists all around the world. That image was a huge confirmation of Einstein's theory of general relativity and gave us a whole new perspective on these mysterious objects.
It's just incredible. So let's try to recap everything we've learned about black holes. We've got these stellar mass black holes, which are formed from the collapse of massive stars, and they're relatively small, a few kilometers across. Then we have the supermassive black holes, which are millions or even billions of times more massive and reside at the centers of galaxies.
Right, and all black holes are defined by their incredible density and the presence of an event horizon, that boundary beyond which nothing can escape, not even light. And while they might have a reputation as cosmic vacuum cleaners, They don't actually suck things in from afar.
Yeah, their gravity works just like any other object's gravity, just much, much stronger the closer you get. And even though they're invisible, we can detect them by observing their effects on nearby stars and gas, and even capture their silhouette with the help of a planet-sized telescope.
That's a great summary. And what's really mind-blowing is that these objects, born from the destruction of stars, play a crucial role in the evolution of galaxies. Their activity can influence star formation rates, and they're essential for maintaining the structure of galaxies as a whole.
It's a bit poetic, isn't it? From destruction comes creation.
Yeah, exactly. And they continue to push the boundaries of our understanding of physics, challenging us to question everything we think we know about the universe.
And they're just so fundamentally mysterious and awe-inspiring. So while the name black hole might sound intimidating, maybe we can now appreciate them not just as destroyers, but as these profound mysteries, these engines of cosmic evolution at the very edge of our knowledge, pushing us to explore further and deeper into the unknown.
That's a beautiful way to put it. They're a constant reminder that there's still so much out there to discover.
Exactly. And on that note, I think it's time to wrap up our deep dive into the heart of black holes. I hope you learned something new today and maybe even had your mind blown a little bit. We'll catch you on the next episode where we'll be exploring another fascinating topic. Until then, keep looking up and keep wondering.
Keep exploring.
See you next time.